All right, let's move on to the new things. So हमने last time functions देखे, फिर हमने give an example of a log function, and then we moved on to relations. Relations के बारे में हमने ये कहा था कि relation is a subset. Every relation is a subset of Cartesian product. Okay, a binary relation is Cartesian as a subset of Cartesian product of two sets. Okay, और दो sets एक ही set की दो copies भी हो सकती हैं. So this was one relation जिसमें एक set हमारे पास cameras थे और दूसरा set हमारे पास servers machines थे. Okay, ये हमने example देखी थी. This was an example हमने लिखी है. अच्छा, so हमने last time ये this is where we were I think. Yeah? हमने ये कहा था कि to represent a relation we can use एक तो हम ये कर सकते हैं कि हम दो elements हैं x और y, तो हम x r y लिखते हैं. Okay, which means कि x and y is a pair. Which means that XY pair is in my relation R. Okay, this is one way to write it down. इसको pictorially भी हम लिख लेते हैं. हम for example लिखते हैं कि X arrow Y. Okay, similarly let's say मेरे पास तीन elements हैं और फिर ऐसे हैं और ऐसे हैं. Okay, तो ये अगर picture है मेरे पास, तो this picture is same as saying कि X Y Y Z and xz are, this is my relation. Okay, so this whole set is my relation. Okay, इसको ऐसे लिखने का को हम पिक्टोरियली ऐसे भी लिख सकते हैं कि x arrow y, y arrow z, z x arrow z. Okay, अब x, y और z की पोजीशन इस तरह की पिक्चर में कोई मैटर नहीं करते. z को हम ऊपर भी लिख सकते हैं, साइड पे भी लिख सकते हैं. Right? But it just means कि कहाँ से एरो कहाँ पे जा रहा है. So for example यहाँ पे C1 से एरो S1 की तरफ जा रहा है, which means कि C1 S1 is a pair. Similarly C1 S2 is a pair, and so on. Okay, so that's one way to write down a relation. आपको questions में हो सकता है कि इस तरह की एक picture given हो, and और उसके ऊपर फिर question हो. Okay, so you should be able to figure out कि what is a relation by looking at an arrow diagram. Okay, इसको to be very subtle arrow diagram कहते हैं. Okay, all right, another representation is matrix representation. इसमें आप ये करते हैं कि आपकी जो rows है, this is one set, आपका जो columns हैं, this is another set. Okay, जो rows हैं they actually represent the first set. Remember जो sets हैं हमारे उसका order matter रहता है. आपके पास दो sets हैं A और B और उसके दरमियान relation है, तो फिर उनका ऑर्डर मैटर करेगा. जो रोज हैं दे वुड बी रिप्रेजेंटेड बाय एलिमेंट्स ऑफ ए एंड द कॉलम वुड बी रिप्रेजेंटेड बाय द एलिमेंट्स ऑफ बी. ओके, यहाँ पे तो वी आर फाइन बिकॉज ए एंड बी आर द सेम सेट 1 2 3 4 5 आई थिंक. ओके, एंड everything else would be zero except at the places where A B is a pair in the relation. Okay, if A B is a pair in the relation, तो फिर इस ये जो मैट्रिक्स हमारी पास बनी है, let's call it M. M का जो A B सेल होगा, this would be one. Okay, so for example यहाँ पे आपके पास this is one. What it means is that 2 3 should be a relation. So is 2 3 a relation? Yeah, see 2 3 is a relation. Okay, अच्छा, one more thing जो मैंने आपको डायग्राम में नहीं बताई वो ये कि अगर आपके पास दो एलिमेंट्स हैं A and B and then you have a relation from A to B and you have a relation to B from B to A, तो फिर आप इसको डबल एरो से भी शो कर सकते हैं. Okay, just one arrow pointed both ways. All right, I think we are fine. Yeah, we have seen couple of
सर
yeah.
सर ये जो आपने ए बी को रिलेशन में किया और मैट्रिक्स की ए बी 1 की है, इसका हमें कॉलम और रो का कैसे पता लगा?
So मैंने ये कहा था कि each row represents an element in A, okay, and each column represents an element in B. Okay, so for example this 2 was an element in A, similarly 3 was an element in B. Okay, so it means कि ये जो cell है, this cell represents 2 3. Okay, अब 2 3, if 2 3 is a pair in my relation, तो फिर उसमें जाके मैं 1 लिख दूंगा. Okay, तो यहाँ पे ये this 2 represents A and this 3 represents B. Make sense?
तो सर ये जो रो 0 में 2, 3 और 4 जो है वो 1 है, वो भी ये लेफ्ट वाले पिक्टोरियल डायग्राम के ही रिलेटिव है?
I think so. I think so. So let's have a look. So for example, this is 1, 2, okay, which means that this arrow, sorry, this arrow, okay, this arrow. Similarly, you have 1, 3, so this is this arrow. You have 1, 4, so this is this arrow. Okay, 1, 5 is 0, तो 1 से 5 arrow नहीं है.
थैंक यू सर.
Excuse me, sir.
Yeah, sure. क्या?
ये जो left पे जो arrow diagram है, so how do we tell that which element is which sets? Because right now they're both the same set, and how are we supposed to know? Okay, हम ये
Arrow diagram, yeah, sure. Arrow diagram is usually very helpful when two sets are same. But if they are not, what we do is हम इस तरह करते हैं कि let's say मेरे पास दो sets हैं, X, which is X, Y. That's a bad name for set X. Let's say X पे मेरे पास elements हैं A, B, and C. Okay, and I have a set Y, and I have elements 1 and 2. Okay, and then I have a relation which is a subset of X cross Y, and it's equal to, let's say 1 to तो नहीं हो सकता, A1. Okay, or let's say B2. There are only 2 elements just to help me. So X may you will have 3 elements. So make 3 elements A, B, C, and Y may you have 2 elements. Okay, so 1 and 2. So you have A2, A1 था कि 2 था, I don't know. A1, okay. So you will have this arrow, and you have B2, so you would have this arrow. Okay, so that's one way to do it.
So, but I don't think you understood my question. My question was that like right now these are 2 different sets, and we can differentiate between the elements. This set X has A, B, and C. Set 2 has 1 and 2. But this in the example in the slides, they're both the same set. So how do we tell which element belongs to which set? Because right here, I don't know if the one pointing to 2 is actually the one from set B or from set A. That's my question.
So देखो, for any arrow, pick any arrow you want. उसकी जो tail है, it represents the first set, और उसका जो head है, it represents the second set.
Oh, okay.
Make sense?
Yes.
Okay, great. Okay, so जैसे for example, यहाँ पे आपके पास दोनों side पे tails है, तो it represents कि यहाँ पे actually there are 2 arrows from here to there and here to there. Okay? So you know.
So we have to represent both relations.
Yeah. So not both relations, but 2 elements in your relation, 2, 3, and 3, 2.
So it would represent in the matrix diagram. We would represent it for both sides.
2 cells. So 2,
by making
3,
B
and
the
3,
first
2.
one and A the first one as well.
Yes.
Okay, I understand. Thank you.
Okay, good, cool. Awesome. Any more questions? You want to say something? Okay. All right. Here's another example. You have a set A, which is ROTPC. These are characters or alphabets from English. B is set of words, discrete, math, proof, proposition. Okay, and we define a relation of the type letter and word. Okay, इस तरह का pair होगा हमारे पास relation में. And an element is in my relation if the letter occurs in the word. Okay, so if R occurs in, for example, math, I would get R math as a pair in my relation. Okay, but it does not, so R math will not be there. But R discrete would be there because R appears in the discrete. Okay, similarly, R proof would be there, R proposition would be there. Okay, so this is another way to do it, and this is its representation as an arrow diagram and a matrix. Okay, जब आप matrix इस तरह की बनाएंगे तो I would require कि you actually mention कि ये row क्या represent कर रही है. Okay, so I think this row represents characters R O T P C, and this represents words. Okay, so discrete. Math, I think second was math, and so on. Okay, so for example, there's an arrow from R to proof.
It's the other order.
What?
The order here is
the
different.
order is wrong. I think this matrix is wrong probably. No, I think this is fine.
No, the matrix is fine, but the order is according to the labels mentioned here. Proposition comes first, then maths, then proof, and then discrete.
Okay, yeah, you're right. This is not discrete. This is proposition. You mean? Yeah. Okay. Right, you're right. Proposition is the first column, math is the second column, proof is the third column, and discrete is the last column. All right, so there's an arrow from R to proof because R appears in the proof, and there's no arrow from R to math because math does not have the letter R. Okay. Similarly, we will see that R1, R proposition is 1, R math is 0. Similarly, O math is 0, and T proof is 0. So T to proof should not be an arrow. ये वाला arrow नहीं है हमारे पास.
लेकिन matrices में अगर rows और columns exchange भी करते हैं तो I don't think उससे कोई फर्क पड़ता है.
So it's a tradition. इसमें हम यही रखेंगे. जो हमारी row है, they will represent our first set, and columns will represent our second set.
नहीं sir, I meant कि rows को आपस में exchange कर दें या columns को आपस में exchange कर दें.
Oh, yeah, that should be fine. Yeah, that should be fine. You just मैंने यही कहा है. You should label the rows. It does not matter कि आप R को पहले लिखते हैं या O को आप पहले लिखते हैं. That's perfectly fine. Yeah, just label it. कि which row is which.
But I have a question.
Yeah.
कि when we are जब हम इस तरह लिखते हैं कि letter comma word.
क्या?
So we're saying. So when we say that A into B, we mean that there are it's a Cartesian product of A into B, right? मतलब
Yes.
A पेड़ में हमेशा पहले आएगा.
Yes.
Right. So if we say A into A, does that mean कि all the arrows की जो tails होंगी, they are coming from the first A and they are going to the second A? Because
Yeah.
in a relationship, always
Yeah.
the
So the
tails-
thing is, देखो, अब थोड़ा सा इसमें ये interesting है. Actually, it's a good point. So the thing is, when you write A cross B, what you do is you list the elements of A and then you list the elements of B and then you make arrows like this, right? When you have the same set, A cross A, तो अगर convention same है, तो you should make the elements of A and then again elements of A और इस तरह arrows बनाने चाहिए. But we don't do it. हम ये करते हैं कि हम सिर्फ एक दफ़ा A के elements लिख लेते हैं, okay? So for example, let's say A के elements R, O, T और P है, okay? और फिर अब हमने we need to send an arrow from let's say R to P, okay? So we'll send arrow in the same set, okay? We'll just make sure कि हम जो pairs हैं वो सारे के सारे यहाँ पे represent कर दें, okay? We don't make another copy of R, we don't make another
When
copy of P.
the arrow goes from B to R, that means कि it is going from
Yeah.
the
So
first A.
head and tail tells you कि आप कौन से A की बात कर रहे हैं, okay? Actually, good point, right? Tail tells you कि it's the first A and the head tells you it's the second A. Good. Okay. So again, इसको करने का मकसद ये है कि if I give you a relation, हम describe कर दें, तो you should be able to come up with a diagram and should be able to come up with a matrix representation. All right. Okay. Let's move on. We are going to see some properties of binary relations. One of the first famous properties is the reflexivity. A relation is reflexive if there is an arrow from an element to itself. Okay? If there is an arrow from an element to itself, for every element we say that such a relation is reflexive. Reflexive only makes sense for relation जो A cross A type के हों, okay? जो same set के ऊपर है. उसके अंदर for every element, for example, ये कहने जा रहा हूँ मैं कि 1 1 would always be there, okay? So if A is 1 2 3, तो फिर ये वाले जो तीन elements हैं ना 1 1 2 2 and 3 3, these elements will always be there. हो सकता है इसके अलावा भी बहुत से elements हो, लेकिन ये वाले तीन elements ज़रूर होंगे. If any one of them is missing, we say that this relation is not reflexive. Okay?
So can you kindly please explain it again?
Yeah, sure. If reflexive का मतलब ये है कि sort of you're looking in the mirror, right? And you're looking at your reflection, which means that every element should be able to relate to itself. Okay, वो अपने आप को तो जरूर देख सकता है. हो सकता है he can see probably other things as well, other elements as well, but he can definitely see himself. So if the relation is reflexive, there should be relation from one element to itself for every element. So if your set जिसके ऊपर आपका relation define है, it contains 1, 2 and 3 elements, तो उसके 3 pairs जो बनते हैं 1, 1, 2, 2, 3, 3, these 3 pairs would always exist in a reflexive relation. Okay, if only one of them is missing, तो फिर वो relation reflexive नहीं होगा. 2 are missing, reflexive नहीं होगा. Okay, these 3 elements are necessary part of every relation defined on the set.
So this is only possible if we have cross product between 2 of the same sets, right?
Yes, yes. It only makes sense for a relation which is from a set to itself. All right, and that's how we represent a reflexive relation. That you have an arrow from a node to itself. Okay, ये arrow आपके पास बने हुए. This arrow, this arrow, this arrow. These 3 arrows show that this relation is reflexive. I don't care about any other arrows, but ये 3 arrows है ना, they show that this relation is reflexive. Okay, so all 3 of these 4 of them are reflexive, because for every element I have an arrow from the node to itself. All right, simple enough. All right, इसकी जो opposite term है, which is anti-reflexive. Relation is anti-reflexive if for every element उसका जो reflection है वो नहीं है. Okay, it's not there. So if you have a set, again 1, 2, 3. Okay, इसके ऊपर कोई relation है x, and we say that this is anti-reflexive. तो हमें ये पता है कि x के अंदर 1, 1 का जो पेयर है ये डेफिनेटली नहीं होगा. Okay, we know that x के अंदर 2, 2 का पेयर भी नहीं होगा. Similarly x के अंदर 3, 3 का पेयर भी नहीं होगा. Okay, ये जो 3 रिफ्लेक्टिव पेयर्स हैं ये एंटी रिफ्लेक्सिव रिलेशन के अंदर नहीं होंगे.
So in the previous slide,
Yeah.
ये जो ये रेड वाला या ग्रीन वाला बनाया है,
Yeah.
if the relationship between the upper and the lower one does not exist,
That's perfectly fine. Yeah. So for example, अगर मेरे पास यही सेट है ये 1, 2, 3 वाला, और इसके ऊपर मेरे पास ये रिलेशन है. So let's say this is 1. So this means कि 1, 1 is there, and this is, let's say 2. It shows that 2, 2 is there. So this is 3. This shows that 3, 3 is there. This, I don't care about any other arrows. This is reflexive now. Okay. And if it's anti-reflexive, so I want to make sure that there is no loop. इस तरह की चीज़ों को हम loop कहते हैं. An arrow from a node to itself. Okay. So in a reflexive relation, every loop should be there, and in an anti-reflexive relation, no loop should be there. There should not be any loops in anti-reflexive.
अगर कोई ऐसा सेट है जिसमें सिर्फ एक लूप है, सारे एलिमेंट्स लूप नहीं कर रहे हैं, so that's neither reflexive nor anti-reflexive.
Yeah, good point. तो इस तरह का सेट जिसके अंदर कुछ लूप्स हैं और कुछ लूप्स नहीं है, it's not reflexive and it's not anti-reflexive. Okay? So here's an example of such a relation. This is a relation. इसमें we have some loops, but we don't have every loop, which means कि ये reflexive नहीं है because we don't have an E to E loop. Okay, and this is not anti-reflexive because we have a A to A itself loop. Okay, so it's possible to have a relation that's neither reflexive nor anti-reflexive. Okay, the second property is the transitivity. Transitivity says that if you have a relation between x and y, I should not say between because it's direction matter करती है. If there is a relation from x to y and there is a relation from y to z, तो फिर ये वाला relation ज़रूर होना चाहिए, transitive relation, which says that you should have a relation from x to z. Okay, so if there is a arrow from x to y and we have an arrow from y to z, then ये वाला जो arrow है ना, this arrow must be there in a transitive relation. Okay, if for some three elements इस तरह का कोई arrow missing है, तो हम उसको ये कहते हैं कि this is not a transitive relation. Okay, so let's have a look whether this relation is transitive or not. Okay, so for example, I have yeah, so this is transitive, और उसके अलावा मेरे पास yeah, I think this is a transitive relation. Okay, this is transitive for every, so sort of इसका मतलब ये है कि if I have a 2 length path to Z, I must have a 1 length path to Z as well. Okay, if I can get to Z in 2 hops, I should be able to get to Z in 1 hop as well. Okay, so sort of intuitively it means that I can go from X to Y and then Y to Z, then I should be able to go from X to Z directly.
Sir, last week जो slides आपने कराई थी उसमें there was a question that if D divides a certain number and then that certain number divides another number, then D
Yeah.
divides that number.
Yeah,
So could this relationship be used in that situation as well?
definitely. It shows that जो divisibility वाला relation है, that's transitive. Okay, that अगर वो वाला हम
Okay,
theorem prove
thanks.
कर लें, तो that shows that a relation of on divisibility के ऊपर base करें हम, जो कि ये था, ये वाला जो relation है, x y, x divides y, इसको हम x r y भी कह सकते हैं, okay? And then we can define r to be divisibility, तो फिर this relation is transitive. Good point.
But you just mentioned that if we have a two-step transition to another element,
Yeah.
we must have a one-step too.
Yeah.
लेकिन अगर it has more than 2 steps, it would still be.
So 2 step तो होगी ना फिर. If you have a 3 step, तो फिर 2 step भी तो कहीं ना कहीं होगी, right? Right. So for example, I don't know if let me try to make a okay. So let's say this is x and it's related to y, and then y is related to z, and then z is related to beta. Okay. To make this thing transitive, एक तो आपके पास ये वाला arrow जरूरी है. Okay. You must have this arrow. Similarly, ये वाला arrow भी होना चाहिए आपके पास. Okay. ये जो third arrow है ना, ये वाला, ये जरूरी नहीं है. You don't necessarily need it. If it's there, you're fine, but you don't really need it.
But we will be needing it because there is a relationship from x to y and then y to beta. So then there must be a 1 to y.
Yeah, you're right. You're right. Perfect. You need it. So the thing is, if you need this arrow, right? Once you have this arrow, now you need this arrow as well. Okay. You're right. Perfect. Nice. Good catch.
Sir, can we say that like either of these arrows can be removed if like the rest of them exist?
But that would mean that it won't be transitive.
Yeah, I guess so. I did not understand the question actually. Can you repeat it?
Yes, sure. I meant like either of these arrows, like any one of these arrows can be removed if the rest of them exists. Like if the other arrows are there, any one of them can be removed. Like you said that it's not necessary. So can it be inferred that if one of these arrows is
So-
removed and the rest exists?
Let me
transitive.
rephrase what I said. Okay, so I said if you have an arrow from x to y and y to z, then this arrow must be there. Okay, you can't remove this arrow for this relation to be transitive. Okay, if this is transitive, so here you must have an xz arrow. Okay, similarly, if you have a yz and z beta arrow, so here you must have a y beta arrow. Okay, you can't remove this y beta arrow. Okay, but within this relation, if you remove x y arrow, you're perfectly fine. It does not harm anything. Similarly, if you remove y z arrow, you're perfectly fine. It still remains transitive. Okay, so some of the arrows can definitely be removed. Okay? So for example, one nice thing to do is remove all the arrows and the relation remains transitive. Okay, so once again, let me repeat it. What the statement says that if x r y and y and z, then you must have x r z. sorry मैं यहाँ पे कुछ
Sir, ये YRC.
क्या
हाँ,
क्या
ये.
क्या okay, so this is the statement we are saying कि for transitivity this should be true. Okay, so again जब मैं सारे arrows remove कर दूंगा तो फिर मेरा hypothesis false हो जाएगा, और जब मेरा hypothesis false हो जाता है then the statement is
true.
yeah, statement is vigorously true. All right, awesome. Okay, so that's transitivity.